Hello everyone. In this video, we're gonna see how to multiply two or more matrices with varying dimension. Okay, so to multiply two or more matrices, or let's start with to multiply two matrices. The first rule or the major rule is that the number of columns in the first matrix must be the same as the number of rows in the second matrix. So first, right, so you need to check if the number of columns in the first matrix is equal to the number of rows in the second matrix. If they are not the same, then it means that the product of the two matrices involved is not possible or is not defined. All right, so if I have matrix A and the dimension is n by m, and I have matrix B and the dimension is R by S, then for A times B to be possible, the number of columns in the first matrix must be equal to the number of rows in the second matrix. If these two entities are not the same, then it means that A times B is not possible. All right, so for A times B to be possible, M must be equal to R. And M represents the number of columns in the first matrix, R represents the number of rows in the second matrix. Now, not only does this approach tells us whether the product is defined or not defined, but it also tells us the dimension of the resulting matrix if the product is defined. Okay, so if A times B is possible because M is equal to R, then the outer entities, which is N and S, represent the dimension of our resulting matrix. All right, so if M is equal to R, then A times B is of the form N by S. All right, so let's look at real examples. If I have matrix A and the dimension is 2 by 3, and I have matrix B, dimension is 3 by 7, then for A times B to be possible, the number of columns in the first matrix, which is matrix A, must be equal to the number of rows in the second matrix, which is matrix B. And since 3 and 3 are the same, it means A times B is possible. If it's possible, then it means that the numbers outside, which is representing the number of rows in the first matrix and the number of columns in the second matrix, is going to be the dimension of our resulting matrix. So the dimension of our resulting matrix is going to be 2 by 7. Again, if I have matrix A, dimension is 100 by 8, and I have matrix B, 8 by 1, then is A times B possible? The answer is yes. A times B is possible because the number of columns in the first matrix is equal to the number of rows in the second matrix, all right? And so A times B is possible. And the dimension of A times B is 100 by 1. Okay, now if I have matrix A, dimension is 2 by 1, matrix B, dimension also 2 by 1. Is A times B possible? The answer is no, it's not possible. Simply because the number of columns in the first matrix is not the same as the number of rows in the second matrix. So A times B is undefined. It's not possible to find A times B. Okay, if I have matrix A, which is 2 by 2, and I want to multiply it by another matrix, matrix B, which is also 2 by 2, then is A times B possible? Yes, it's possible because the number of columns in the first matrix is the same as the number of rows in the second matrix. And the dimension of my resulting matrix is going to be a 2 by 2 matrix. If I have matrix A, which is a 3 by 2, matrix B, which is a 2 by 5, then is A times B possible? Yes, it's possible because the number of columns in the first matrix is the same as the number of rows in the second matrix. All right, so A times B is possible. And if it's possible, what is the dimension of our resulting matrix? The dimension of our resulting matrix is going to be a 3 by 5 matrix. All right. And so with this in mind, let's look at how we can perform this operation. That is matrix multiplication, or the product of matrices. Okay, so let's start with simple ones. I have matrix A, which is equal to 1, 2, 3, 4. All right. And then I have matrix B, which is equal to, let's start with a column vector. Say 9 and maybe 4 here. I want to use a different one, 5. All right. Then A times B, we first of all check whether it's possible, and then if it's possible, we need to check the dimension of our resulting matrix. Okay, so the dimension of our first matrix is a 2 by 2, and the dimension of our second matrix is a 2 by 1. Now, is A times B possible? Yes, it's possible because the number of columns in the first matrix is the same as the number of rows in the second matrix. All right, so these two are the same. And so A times B is possible, and the dimension of our resulting matrix is going to be a 2 by 1. All right. So let's look at what A times B will give us. All right. So A times B is equal to our first matrix 1, 2, 3, 4, and it's multiplying matrix B, which is 9 times 9, 5. Now to multiply two matrices, we pick the row of our first matrix and multiply it by the column of our second matrix. Okay, and so let me use a different ink. We pick the row of our first matrix, multiplied by the column of our second matrix. So it goes like you're writing a 7, right? So pick the row and multiply it by the column. Pick the same row, multiply it by the column. Okay, so we pick the first row, row 1. If we are multiplying by the column 9, 5, then it means that 1 is going to be matching onto 9, and 2 is going to be matching onto 5. Okay, we multiply these two corresponding components, and the results, we sum them. Right, then we come and pick out the second row since there are no other columns, 3 and 4. So 4 will match onto 9. Sorry, 3 will match onto 9, and then 4 will match onto 5. Okay, and so A times B is going to give us, we pick 1, it matches onto 9, so we multiply these two, 1 times 9. Then pick 2 multiplied by 5, so we have 2 times 5. Now these two components, or these two products, we sum them. Then we come and pick the second row, which is a 3, 4, and then multiplied by the same column. Right, so 3 will match onto 9, so 3 times 9. Give me, so 3 times 9, and then 4 will match onto 5, 4 times 5. Now these two products, we sum them, and the results we get 1 times 9, that will be 9, 2 times 5, that will be 10. If you sum them, we're getting 19. 3 times 9, we have 27. 4 times 5, that will be 20. So 27 plus 20, that will be 47, which is a 2 by 1 matrix. All right. Now let's look at when we have a C to B, 5, 6, 7, and then 8. All right, so let's see if we can find AC, if it's possible. All right, and the dimension of our first matrix is 2 by 2. Dimension of our second matrix is also a 2 by 2. The number of columns in the first is equal to the number of rows in the second, and so the product is defined. And if it's defined, the result is going to be a 2 by 2 matrix. Okay, so our A times C is our first matrix, 1, 2, 3, 4. And then our second matrix, 5, 6, 7, and then 8. Alright, so how do we multiply these two matrices? We pick the first row and multiply it by the first column. The product that we get, we sum them. We pick the first row again and multiply it by the second column. Let's multiply the corresponding components and then results, we sum them. Now, since there are no other columns, it means we're done with using the first row. And then we come and use the second row, multiply by the first row, multiply by the multiply by the first column and multiply by the second column. So A times C is going to give us, we pick the first row 1, 2, place it on 5, 7. So you notice that 1 will be marching on to 5. So we have 1 times 5. And then 2 will be marching on to 7. So we have 2 times 7. And the resulting, we add them. Right? Then there's another column. Unlike in the first one where there was only one column. But here we have two columns. So we pick the first row again and multiply it by the second column. So if you do that, you see 1 marches on to 6, 2 marches on to 8. All right, so we have 1 times 6 and then 2 times 8. Now there are no other columns in here, so we end it here and then we sum these two products. All right, so now we do the same thing as we did using the first row. Now this time around, we're going to use the second row. All right, so instead of 1, 2, now we're using 3, 4. So we pick the second row, place it on the first column, and multiply them. The result, we sum them. So 3 marches onto 5. We have 3 times 5. Then 4 marches onto 7. We have 4 times 7. And the result, we add them. We pick the same row and then place it on the second column. 3 marches onto 6. So we have 3 times 6. 4 marches onto 8, and we have 4 times 8, and the result, we sum them. Okay, so simply we have 1 times 5, this is 5 plus 14, that will give us 19. We have 1 times 6 plus 16, that will give us 22. Then we have 15 plus 4 times 7, that will be 28, and this will give us 43. Here will be 18 plus 4 times 8, that is 32, and this will give us 50. All right. Now let's see if we can get the same results using Python. Okay, so we have the same two matrices that we've been using so far. Okay, so we don't need to rewrite this. We just simply go to print. Go cut dot. Now, since this time around, it's not just any multiplication, but the multiplication of matrices, there is a special inbuilt function for multiplication of matrices, which is known as matmul. All right, so to multiply the matrices, we invoke matmul. Mat means matrix, mul means multiplication. Okay, so this dot matmul, open the bracket. Now, the product of matrices is not necessarily commutative. Okay, what this means is A times B is not always equal to B times A. And so you need to make sure that the first matrix that you input corresponds to the first matrix in the product form. All right. In the product form, we have A times C. That means our first matrix is matrix A and our second matrix is matrix C. In the product of matrices, the arrangement does matter because A times C is not necessarily the same as C times A unless C is the identity matrix. Then A times C is equal to C times A. But if that is not the case, then please make sure that If it's A times C, then the first matrix that you input in here represents the correct order. All right, and our correct order is A and C, not C and A. All right, but in here our C is B, so we have A, comma, instead of C, it's B. Okay, so we run this and we get in 19, 22, 43, 50. Just like we got when we did it manually, 19, 22, 43, 50. All right, so make sure the arrangement is in correct order. Now let's see what would have gotten if we had messed up the arrangement. So print Booker dot matmore, open the bracket. So now we do A, comma, so B, comma A. All right, we run it. Say we've gotten 23, 34, 31, 46, which is not the same as 19, 22, 43, 50. So A times B is not B times A. So make sure that if it's A times B that you're looking for, then the correct order is A, comma B. If it's B times A that you're looking for, then the correct order in here should be B, comma A. Okay, now to perform this same operation in Excel, all right, so let me bring it here. A times B, just like under Python where there's a special formula, sorry, a special function for matrix multiplication, in Excel there's also a special function that does the matrix multiplication, and that special function is known as mmult. Mmult, and the first M represents matrix and the mult represents multiplication. In Python, okay, the function is called matmore. In Excel, the function is known as mmult. Okay, so please take note of that. So if I'm going to perform this multiplication, the first thing I need to know is what is the dimension of my resulting matrix, because that is where the answer is going to be, right? And since these two are all 2 by 2 matrices, if I multiply them, my result is also going to be a 2 by 2 matrix. Okay, so I select a 2 by 2 grid that represents the dimension of my resulting matrix, and every equation in Excel start with the equality sign. So once I've selected the grid where my answer is going to be, I start with equal to, all right, then mmult. Mmult takes 2 arguments. That is your first array and your second array. The first array represents the first matrix, and the second array represents the second matrix. Okay, and so do not interchange them, otherwise you're going to get a wrong answer. All right, now I'm looking for A times B, so my first array is matrix A. Now depending on what operator you have in between, in mine I have the semicolon, in some they have the comma, in some they have the colon, so be watchful of what you have in between. All right, so after I've selected my first array, I bring my semicolon. Okay, then I select my second array, I close the bracket and press Ctrl Shift Enter, and that is giving me 19, 22, 43, 50. We had the same thing when we did it manually, 19, 22, 43, 50. We had the same when we used Python, 19, 22, 43, 50. Now let's look at what we'll get if we had just swapped them around. B times A. Okay, so we select the grid that our answer is going to be. This is equal to mmult, open bracket. All right, then we select our first array. Our first array this time around is matrix B, my semicolon, select matrix A, close the bracket, Control Shift Enter, and that gives you 23, 34, 31, 46, which is the same over here. 23, 34, 31, 46.